Hello, everyone, and welcome to our virtual conference, Fight Complexity with Flexibility, How Self-Service Software Can Help Teams Innovate Faster. I'm Greg Orloff, IIoT World's Chief Innovation Officer, and I'll be your host for this virtual conference. So on behalf of our entire team here at IIoT World, thank you for joining us today. Just a little bit about us as an organization. IIoT World is a digital media publication that covers the economic and technological implications of the transformation that's taking place in the industrial IoT space as it proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the Internet of Things globally. IIoT World has recently ranked by K-Core Analytics as the #1 global influencer on several topics that include industrial, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. Our mission is to help companies create a culture of innovation and connect smarts. Industrial, technology, manufacturing, sensors, and the CXO decision makers within organizations. Today we have an exciting panel representing the companies Krauser Technologies, MachNation, and Valmet. In this 2-hour virtual conference, we'll discuss the need to control the cost and complexity of IIoT, the role of edge analytics, and how self-service software can help teams innovate faster. We will answer questions such as, what is happening in the market today? How can edge analytics play a role? Lessons learned from Valmet industrial internet initiatives. And in what way can self-service software increase collaboration and speed of innovation? Our co-founders, Carolina and Lucian, will monitor the online channel, so feel free to send your questions in the live chat on the Zoom conference link or via Twitter using the hashtag IIoT Edge. Our first session today is entitled Industrial IoT Market Overview and Insights, and will be presented by Dima Tokar, co-founder and head of research at MachNation. In this session, you will learn about the current state of the industrial IoT market, success factors for IoT implementation, and some key findings from 2018. A little bit about Dima. He is the co-founder and head of research at MachNation, the only analyst firm exclusively dedicated to testing and researching Internet of Things platforms, middleware, and services. His primary area of expertise are in technology analysis, product management, and product marketing of IoT platforms, as well as software and services. Prior to co-founding MachNation, Dima held positions in technology and marketing at Verivo Software and Fixu. Dima is a leading speaker at client and industry events and is highly quoted in the business and trade press. His work on IoT application enablement and device management is highly cited by participants in the IoT ecosystem. Dima holds a degree in microbiology from the University of Massachusetts Amherst and a business administration degree in finance from UMass Amherst's Eisenberg School of Management. So I will turn the floor over to you, Dima, for your presentation.
Thank you very much, Greg, it's a real pleasure to be here. Thank you all for joining. I wanted to kick things off with an overview from our perspective, an industry analyst perspective around what is happening in the market today when it comes to industrial IoT. And I wanted to share some trends with you and share some color in terms of what's happening in the market today from our lens. And so brief overview of the company. Wanted to share a little bit about who we are at MachNation. And so we're broadly described as a technology benchmarking firm focused on enterprise and industrial IoT. So we are a company that really tries to focus and understand the technologies that enable industrial and enterprise use cases to actually come to fruition. We're based in Boston, Massachusetts in the United States, and we are in the 6th year of business as industry analyst firm in IoT. In terms of what we offer and why we are qualified to speak on this topic, we spend the entirety of our business focusing on comprehensive technology and strategy research. We, like many other analyst firms, produce a variety of different publications and scorecards, but more importantly, we have a hands-on platform evaluation and testing environment called Mighty. So we actually use the technology ourselves, and we put the technology through a set of rigorous tests in order to make sure that it meets the enterprise and industrial requirements that the market demands for today's IoT deployment. In 2014 was our first scorecard analysis, and in 2017 we released a Mighty that I just described as the hands-on way to evaluate IoT technology. Okay, so jumping right into the sort of the interesting trends that I wanted to share with you today. What's happening out there? It's an interesting space in the IoT landscape today. There's a lot going on. There's a lot of noise in the market. There's a lot of buzz. There's a lot of marketing that's happening out there. And so something that I wanted to do is try to boil that down for you in essentially 5 takeaways. And I want to sort of keep it high level, keep it brief, but sort of distill and bring together all of the information, all of the things that are happening from the vendor side, from the enterprise side, from the service provider side, and share with you some sort of overall findings that we think are particularly relevant and important when we talk about the edge, when we talk about platforms and enabling industrial technologies to take on the role of IoT that everybody wants them to. And so the first trend that I want to share with you is that the right technology speeds time to market 5x. And so what we mean by that is that the right platform allows you to accomplish development, deployment, and operations of the IoT solution 5 times faster than an average platform. And there are a lot of companies out there today that have technologies that are dubbed as platforms, and from our research, from our hands-on evaluations, we have found that there's a pretty big discrepancy between a variety of players out there, even though sometimes on the surface the marketing might sound very similar. And so, why does this technology matter? Well, it really allows you to deploy your solution faster. It allows you to use less resources, both from a compute standpoint, by providing an efficient technology to process your data, and also less resources from a human capital perspective, preventing the IoT solution business unit from needing to staff at very high levels in order to achieve those lofty goals of IoT. And of course, the key value and the key reason why you want to get to market faster is that the enterprise, the industrial enterprise, can start delivering value to both yourself internally as well as to the customers that are looking to have a connected product or connected solution be made available to them. And so, from our perspective, what we're finding is that these kinds of findings and the differences between the platforms are things that you can only really find if you actually use the technology. It's not something you can distill just from hearing marketing decks from a variety of players, just because the nuance is really in the technology that's built. Trend number 2. So from our perspective, 80% of industrial IoT deployments will rely on both edge and cloud computing. And I think earlier on, maybe 2 years ago, 3 years ago, there was a more of a discussion of is it all about the edge? Is it all about the cloud? What is the business model that enables industrial IoT? And from our perspective, it's not really that conversation. It's edge and cloud. There are components in a majority of industrial solutions that require both edge elements, things that are close to the point of asset data generation, as well as more centralized cloud computing elements where big data analytics and visualization and other processes just make a lot more sense once data has been aggregated. And so to address the business requirements of a majority of these solutions, there is going to be something in the edge and something in the cloud. And the way we know this is again through the hands-on work that we do. And our findings in our test lab show that there are key workflows that indicate a strong need for both edge computing and cloud computing in IoT. We run through a variety of tests that allow us to determine how data needs to be processed and normalized and aggregated and ultimately delivered to the end user. And our testing suggests that it's done with a combination of edge and cloud technologies in order to optimize the process both for cost and for time to market. Number 3, we have found that most enterprises lack IoT fluent developers and data scientists. And so what does that mean? So IoT, from our perspective, is really all about delivering some kind of value either internally or to your customers. And so the first sort of inning, the first half of IoT has been about getting asset data to the right place. And for the most part, enterprises are starting to grasp what that really means and how that's really going to impact their business, what technologies they might want to deploy. Now, the hard part and sort of the holy grail of IoT is making sense of that data and taking all of that insight coming from assets, from enterprise systems, from users, and distilling it into something that's meaningful, something that can tell you something you didn't know before, or it can predict something about the future that would have been otherwise hard to predict, or it can maybe offer you a better relationship with your customers that otherwise would have been difficult to do in a less connected world. Now, that is great, but however, enterprises are not often built with data science teams and developers that really understand how to deal with data. So that's why we believe that the use of self-service analytics and technology that allows data to be synthesized in a way without having a very heavy investment in such data scientists is a key trend when it comes to industrials and enterprises. We think that's something that companies investing in IoT should really be focused on, is empowering their business analysts, their project managers, quasi-technical users to be able to use some kind of technology to derive value out of the IoT data that's being generated. Number 4 trend that I want to share with you is that building is always tempting, but it's rarely the right decision for an enterprise. And so what I mean by that is there is always a discussion happening within the enterprise around which part of the IoT solution should be built in-house and which parts you should go out to a vendor. And the discussion usually goes around wanting to build something because it creates a competitive differentiator and allows you to perhaps have a little bit more control over the entire solution, versus the buy scenario, which is really all about time to market and allowing companies that are experts in something offer you a solution, offer you a technology, offer you a service that will get you to market much more quickly. And so at Machination, what we've done is we've built a total cost of ownership model to look at how industrial and enterprise IT solutions are deployed both from a build scenario and a buy scenario. And our finding is that for a typical enterprise IT deployment, it's roughly 80% less expensive to go to a vendor rather than to build something in-house. And our quantitative data shows that it takes probably tens of millions of devices to be connected before it could possibly make sense to build something from scratch. And so for that reason, the only companies that we see that should realistically be considering build something in-house are oftentimes carriers, telecom companies that are building something highly differentiated and are operating at a global massive scale with tens of millions of devices connected. And the reason why this is an important trend is because we think that making the wrong decision here means cost overruns, delayed launch, and opportunity cost of doing something better with your employees and with your development and data science teams. And so for that reason, we believe that in order to keep up with the evolving market, which is shifting in sort of matters of months rather than years, it's really important to focus on where your core competency really is in-house and really do that in-house, and then go out to vendors that are going to be specializing in various technologies that can enable you to get to whatever business value you want to generate from IoT for your customers. And then finally, the last item that I wanted to mention in my brief portion of the conversation today is that we believe that vendors that have the best developed ecosystems will ultimately win the IoT race. And why do we believe that? Because we think that picking the right platform from an enterprise standpoint is really about finding a technology with an ecosystem that can ensure that the technology will grow as you grow as a business. It will grow when you, from one solution that you've deployed in IoT, which might be some basic monitoring solution, to more complex, more advanced, heavily integrated solutions that touch various parts of your business, such as finance and marketing and client services. And so for that reason, the data that we've collected from the scorecard shows that it's important to find partners from a vendor standpoint that understand that it's really about the ecosystem, that don't try to do everything themselves, but instead create a combination of hardware and software vendor partners within their ecosystem that can work together, that can work together in order to put together something that's holistic, that's comprehensive, that's best in class, but also something that's modular, that allows the solution to evolve over the years rather than relying on that single vendor to innovate for the foreseeable future. And the future steps with an ecosystem are an ability for a marketplace to be fostered where third-party developers, systems integrators can produce a marketplace for IoT apps that can then be deployed, so that when you're trying to deploy a solution that isn't necessarily going to be a core competency, it's something that you can use off the shelf and really focus your efforts on developing those types of IoT solutions that you believe are ones that are going to differentiate you from competition. Okay, so that is what I wanted to share with you today. And at this point, I'm going to pass over the controls.
Thank you, Dima. Some great insight there. Truly appreciate it. Our next session, titled Industrial IoT Edge, How Edge Analytics Can Simplify, Optimize, and Reduce Cloud Costs for Your IoT Projects, will be presented by Johan Jonsson, co-founder and head of sales and marketing for Krauser Technologies. This session is going to talk about using real-life use cases to highlight some of the areas where an edge computing platform can bring both technical and financial value to an IoT project. We'll talk about simplifying, how to simplify both developments, usage, and maintenance when connecting machines to a cloud service. In terms of optimization, we'll look at how to optimize the data flow to the need for bandwidth, enhance security, and prepare the data for further analysis. And finally, from a cost reduction perspective, how edge analytics contributes to the whole architecture for an Industry 4.1 use case. So a little bit about Johan. He has 15 years of experience working with marketing across a wide variety of projects. He possesses a true entrepreneurial spirit, operating between strategic and hands-on details. Johan leads marketing efforts for Krauser as well as the product UI design side of the business. He's worked with web and communication in Sweden and internationally since 1999, focusing on real-time communication and business benefits with real-time communication since 2012. He's convinced that the cloud is great for IT, but not as great for IoT. Johan thinks we need something closer to the data sources. We need fog computing from his perspective. So without further ado, let me introduce you to Johan.
Thank you, Greg. Thanks for that introduction. Hi, everybody. First, I just want to say thank you, Dima, for a great market overview. It's always interesting to hear what you're saying. It's a pleasure having you all today, and I hope that we'll keep serving you with some interesting insights during these upcoming talks. My name is Johan Jonsson, and as you already heard, I'm a co-founder at Krauser and head of sales and marketing. I'm seated in the snowy north of Sweden, where I have been working with real-time applications and intelligent integration since 2012. And over the years, I have seen this business evolve, and I will say that this is really exciting times. Krauser is a Swedish software company that designs and develops real-time analytics solutions for industrial IoT, purpose-built for high-requirement use cases, but simple enough to use for any IoT project out there. The core of Krauser, the real-time engine, has been developed since 2009 and are class leader in terms of reliability, performance, and memory footprint. During 2018, we were named Cool Vendor by Gartner in IoT Edge computing. A proud moment for the team and for the founder of the source code, I would say. The topic of this event relies on edge analytics. I would like to start with a quick walkthrough of the industrial edge analytics setup. Edge analytics is all about processing data as close to the data source as possible, processing data in motion, whereas the cloud is all about processing data at rest and store data for historical use. Streaming analytics at the edge, handling raw data from industrial assets, cleaning, preparing, and performing complex event processing before sending the data to data center or cloud services out there. On this level, on the edge level, it's PLCs and machine executing systems communicating with, let's say, OPC, Modbus, Profibus, and such protocols that has been converted and enriched into MQTT and other protocols better suited for the internet communication. The edge is ideal for running machine learning algorithms and detecting anomalies within milliseconds and perform actions depending on the result of these detections. The cloud is good at training these algorithms with historical data and to send functional updates back to the edge. That was a short and elementary introduction to edge analytics. Let's move over to the topic. Skill shortage. Today, we're talking about the complexity of industrial IoT and how to overcome technical and digital boundaries. But one of the biggest struggles we see in the business is skill shortage. There are simply too few resources out there that can help the industry digitalize. There are currently over 500,000 job openings worldwide for software engineers, according to LinkedIn data, and companies are investing more in digitalization than ever. The skill shortage covers most areas, and few actually believe that the situation will improve. I would say that the opposite is more likely. It's a more likely scenario. To accelerate industrial innovation and digitalization, the industry has to find a way to empower more people with less experience to innovate and participate. Applying data analytics, develop the communication, and bringing the IoT project together is an extensive task. We need to find a way to ease this project while we keep or even raise the level of quality. In a recent discussion with the mining and metallurgy industry here in Sweden, the IT director went through all the difficulties applying IoT to their operations. His first reflection was that the time it takes to evaluate and get into new systems and services. He also pointed out that the organization sometimes can be a bit obstructive when moving into new systems. So it's very difficult to predict the costs of implementing the new systems. Another thing that he pointed out was the business cases difficulties and the unpredictable costs of lifetime for cloud and IoT projects. Due to their experience, it's difficult to protect how much the system will cost over time, and therefore it's difficult to estimate the whole business case. On the technical side, the struggle was fragmentation. Over the years, the company has acquired a handful of smelting plants, and all with different systems and organizations. And now he got the task to bind them all together, bringing legacy protocols and different network setups to the equation, not to mention all the different setups for the sensor data. That's a story that we have heard variation of on almost any of our sales meeting, pointing out the complexity of industrial IoT implementation. The need for flexibility is obvious. We are working with a major forest industry in Sweden that has come pretty far in terms of the digitalization. They are running the standard machine execution system, the MES, and they are retrieving data for analysis on a daily basis. But they are struggling with their security setup and the difficulties to let the machine suppliers connect to the machines that they have delivered. The network architecture and the data policy is making these small projects pretty extensive. Within the IT department, they are short on resources, though everyday business is taking the majority of the time. Helping the suppliers has become an issue when it should be something that's creating value. The architecture and the current system don't provide the flexibility and the ease of use that is needed. In many cases, the current system is actually the bottleneck for the IoT projects to evolve, making this time-consuming and expensive to engage. I noticed a meme circling social media the other day. saying that machine learning is written in Python while AI is written in PowerPoint. I believe that many of us can relate to that statement. These kinds of presentations seems to oversimplify the complexity of an IoT project, and the heading here is no exception. My point is that even though the total scope of your project is complex, you need to find some areas where you can ease the project over time, but you probably need more than one solution to ease the whole project. With that said, I would like to tell you about another customer of ours supplying worldwide factories with machines and services. They highlighted a couple areas where they are looking for solutions that will simplify their everyday work. First, they have realized that they needed some kind of solution for simplifying the data reduction and handling of all integrations on the factory floor. Their base of customers had different systems for running their machines: ABB, Siemens, Beckhoff, Rockwell Automation, and others. Besides that, the customer are also running the manufacturer's own execution system. Another important part was simplified and centralized management and control of the system. Having thousands of machines out there with multiple intelligent integrations and various protocols to consider, they realized that they will run into problems in the future regarding updates and error corrections. Updates and error correction is a high risk in these projects. With their team and partnerships, they had a pretty good experience in programming and software development, and they were impressed with the simplicity in solutions like Node-RED and other drag-and-drop tools to enhance the speed of innovation and development. Especially, they liked the idea of pre-built code modules like OpenC or Modbus or like simple cloud connectors and so forth, for solving the very different use cases and services that the end consumer were asking for. That machine manufacturer came up with the idea of a self-service software, the software that could bridge their internal shortcomings within IoT with their software integrators and their consultants, opening up for non-developers to work directly with the machine data without doing code, just focusing on solving machine performance issues by using, let's say, MATLAB models and anomaly detection functions that they were used to work with. They requested an easy-to-use drag-and-drop environment with pre-built connectors and functions to design the future data communication. They requested something that they could overview all their integrations and data flow, not another IoT platform. They already have a great solution for that. They need an environment where they have full control of softwares and communication running their analysis. They also requested something to simplify the tag management of their connected assets. Though they sometimes were delivering just some machines to a factory, other cases that they deliver the majority of the machines and maybe even the execution system. Therefore, they have a big load of different tags to consider. In terms of tags and sensors, the issue is to know how that should be sorted and cleaned and prepared to fit the Python models that this manufacturer want to run at the edge. As you all know, this is a very complex topic within industrial IoT. Lastly, this machine manufacturer stated that they wanted to prevent future data maintenance issues and struggle with overviewing their integrations. They had previously experienced problems with integration, though that over time they have created a lot of what they called code islands, like small integrations and patches and other stuff that were very, very difficult to overview and maintain over time. That problem just seems to grow the more they try to digitalize the fleet that they have today. They need a solution that they can manage themselves, overviewing and solving the common data issues. For this presentation, we promise to stick to real-life use cases and customer experience, and we promise to give you some examples of how to lower your cost for IoT projects. We know that specialized software and platforms can reduce the time for implementation and maintenance with over 60%, depending on the preconditions. So that's one variable. But when looking into the real need of our customers, we realized that in many cases, they could benefit from bypassing designated cloud services when sending data for storage. If they use their current stack, they could actually process the data locally and just send the results to the cloud, which in some cases lower the total cost significantly, saving more than 10,000 euro per connected site per year. And this was for one use case only. We also realized that the projects struggling with legacy architecture or very strict security architecture were looking for on-premise IoT solutions because they thought that without internet connection, they couldn't run an IoT system. But when looking into their setup, we realized that it was really a matter of choice of protocol and protocol communication. It was actually not the network problem. Machines that couldn't communicate with the web or the internet directly could communicate with MQTT or AMQP instead, opening up for IoT Edge platforms that can be operated via these protocols. Lastly, we could state that the need for intelligent horizontal integration to various systems, that's a hygiene factor. It's not a feature. To make this system work, the user needs independence to test and reject any system or service, and therefore they can't be locked into one solution. They need something very flexible and easy to use. To wrap this up, the takeaways from this session will be: Edge analytics is more than applying the code at edge. It's about making intelligent integration from your asset to any destination out there. Second, the edge should no longer be considered the edge of the network. It is now the start of your IoT integrations and architecture. And lastly, understanding edge capabilities will help you understand how to significantly cut costs for your industrial IoT projects. Thank you very much, and over to you, Greg.
Thank you, Johan. Some great insight, and I love the comments about the transition points between where does the edge stop and the cloud start. So it's great insight there. So Thomas Edstrom will be presenting on our next session, Dialogue with Data in Pulp Mills. Now, Thomas is the General Manager, Industrial Internet Pulp Mills, Pulp and Energy Business Lines at Valmet. So in this session, we're going to cover how to manage multivariable processes and bring improved performance to all pulp mill processes. We're going to talk about how to eliminate shift-to-shift variations in different departments from the wood yard to pulp dryer using predictive controls, and how to enable production and quality targets to meet quicker while optimizing energy, chemical, and raw material usage for additional savings and environmentally clean operations. So Thomas has been with Valmet for more than 22 years, so he's got a tremendous amount of experience to share with us here today. Valmet is the leading global developer and supplier of process technologies, automation, and services for the pulp, paper, and energy industries. Valmet's strong technical offering includes pulp mills, tissue, board, and paper production lines, as well as power plants for bioenergy production. Thomas, the floor is yours.
Thank you, Greg. Yeah. Let's see, I can take the control. Yeah, there we are. Okay, I will update you it's about Valmet technology, what we are doing, and after that I will talk about our industrial and internet offering, what we call, what you mentioned as industrial IoT. And then later on, how do we serve custom with the industrial internet offering we're using our Valmet Performance Center. It's about our environment for Valmet, how to enable global economic growth without risking the world's sustainable future. And depending where the pulp mills are, different environment aspects are more or less important. For example, emission to air can be a very extremely important in one case, another we are missing fresh water. So our raw materials that we're using is waste, agro, wood, and recycled paper. And then based on that, we have different technologies and solutions, and it's in energy, pulp, and paper. My responsibility areas is in pulp. I'm responsible for our industrial internet strategy in pulp. And the end products that we produce is heat, electricity for energy, dissolving pulp to create manufacturing cloth, chemical pulp and mechanical pulp, and paper, board, and tissue machines. But the last year is coming new end product like biogas, biofuels, biochemicals, and so on. Valmet is the world. We are in the world market position in all the markets that we are working on. And with the services and automation, we are supporting our market areas like pulp mills, power plants, paper, tissue, and board machines. Typically, to have an idea of a pulp is an investment cost for a new pulp is typically €1 billion. Valmet is quite, we are 12,000 employees. We have over 120 service centers, 87 sales offices, and 36 production units, and 16 R&D centers. So we have like small pulp mills to test the raw material to give the guarantees to the customer. And we, as you see, we are global. But that's enough for what Valmet is. So if you're going now into the dialogue with data, what do we mean with that? First of all, it's a lot of data in a pulp mill. So it's on process and equipment data. We have thousands of signals existing there, and mill and plant level data and company level data. So using this dialogue with data, we're combining this process and business data from different mill or plant system. We leverage advanced analytics, and Valmet know how to create new data-driven application, providing application for operating assistance and new set points for automation system. Normal what we have delivered in the past is have been focused on controls. Now we're looking more and looking for guidance also based on data-driven analytics. I have an example on the X here. We have successfully eliminated unplanned shutdowns and overall performance, and higher level of analytic intelligence. And I have an example, a customer suffering from unplanned shutdowns and short time of their twin roll press rolls. Twin roll is a washing machine that have two rolls that are squeezing, pushing the pulp between each other. And typically what you do is you make a data collection, process data collected from the customer control system to find correlation between process deviation. So far, so good. But to really come up to a perspective level of analytics, then you also need to add the experts. It's not enough with the data analytics. You also need to have the process expert. Then you see that then the process expert say pulp flow into press is often low compared to roll speed. Too low flow can lead to pulp stagnation and give uneven load. And then luckily we have made an application here that we call twin roll performance monitoring applied. The problem was solved by monitoring the operating window regarding feed flow and consistency. Whenever an alarm appears, the application gives operator recommendation how to react. And that's what I'm saying. We are not taking the control. We are develop application supported operator to be able to run the pulp mill more efficient. Key elements of Valmet Industrial Internet. As I said before, Intelligent machines and automation. Yeah, that's a solid base for industrial internet solution. And then we create an base for an analytic application. Then we create reliability and performance application. And then we are serving that with the Valmet Performance Center. Coming back to tell more about that. But this provides remote support, monitoring, and data analysis and access to Valmet expert network. Valmet Customer Portal, that's the way the unique space the customer have to reach all the industrial internet applications. The EMAS was, let's see, yeah, the EMA was talking about solution ecosystem, and that's extremely important also. But we from Valmet are creating advanced analytics based on our knowledge of our process and machine, but also our sub-supplier like hydraulic unit supply is also doing the analytics. And then it's important that we are building an ecosystem together, that we are showing the result in some common dashboard, because our customer is not expecting to have many different dashboards, so we need to cooperate there. Let's look for some examples of application that we have made in the cloud. So this is the product offering we have right now, and we divide it in advanced reporting guidance, asset reliability optimization, operator performance optimization. I would say, especially in asset reliability optimization, where we are talking on predicting maintenance reliabilities, we are focused right now. That's an area that customer so far doesn't have so much support. We are far from the level of support that you have when you're driving a car. So all this application, what we're providing here is then done in the cloud, with some exception when they require very high speed, when we need to move down to the edge. And we are all this application, and so why can the customer take care of that by themselves? We always have a Valmet Performance Center agreement, and there we have some on-demand expert support, remote monitoring, optimization, analytics as a service. When you're logging into Valmet Customer Portal, then you have access to all the Valmet Industrial Internet application services. And then the first landing page is divided in a status bar, when you can see the status of a certain area. For example, pulp line here, we have a red mark. That means something, one of the application, the pulp line saying is, yeah, you have some problem there. And then you push that one and then come into that application. We have the main KPIs here. Customer can select by the different KPIs that if it is important. Then in the agreement, we have also sending reports, and this report customer will have here. One important thing is the collaboration area. To the right, we have the collaboration area. Customer can, internally in the pulp mill, between the different shifts, communicate, or between different mills, or together with Valmet Performance Center. We don't call it a chat area because we don't reply immediately. This is an example of an application, twin rows press performance monitoring. And we would like to present the status of the machine in a simple way. So we're using donuts, or we're using traffic lights. So it's very easy to find where is the problem. And then you get the recommendation what to do. So this is an overview picture of this application. when we developed this application coming to reliability, then one way we did it was to looking at how is the spare part sales. Spare part sales means that they are wear parts that will need to be changed, and then it's important that we are able to predict when it's time to change these spare parts or wear parts. And then we want to, of course, also connect this to our e-book systems as automatically order that spare part to customer, but that we have not come so far yet. And then you also, if customer want to know more in detail, we have a lot of trends diagram and explaining more in detail what's happened there as a background if you want to dig into all the details behind our recommendation. But it's going more and more that the customer is losing knowledge and need this. They don't want to understand why it's not working as it should. They just want to know when it's time to change, for example, a wear part. Another way is, this is a more, I would say, a new way to develop applications. It's using data analytics as service. Instead of traditional ways, specify a different function and implement it in the cloud. We connect us to the customer pulp mill, and when we have a set of data, and then they start looking at for correlation between data and see if we can find something that is not as it should. And then if you see, okay, we have some findings, then we take a full data set and continue the data analytics. Then we can create and implement these modules and create an operator guidance interface. And this is a new way, I would say, to create applications. It's much more efficient and faster to come up with new ideas. And of course, also next step is using it for controls. So typically, before we're coming to customer, we're also using data analytics as to invest. What is the situation in the pulp mill? And it's a very quick way to do it. Before we have this data analytics service, we need to use the process engineer, and we of course that's also a bottleneck, all the experienced process engineers. This is an example of how the result from data analytics as a service. In a paper machine, web break is a real problem. And it's happened quite often. By doing this, the analyze, then we come up with the most important. We're looking at many signals. I think it's many, it was around 25 signals, and see how they are affecting. And look at them. Then we find out the top 3 most important measurement by time which caused the break. And then we're creating a health score. And based on this health score, when the health score go down, then it means this web break is close to come. And the result with this web break prediction application, that we could predict 50% of the web break before 2 hours before they happen. And very much what we are using is machine learning. It's a great tool for prediction. And in mechanical failures also. Yeah, what is the proven result with our industrial internet? Yeah, reduce quality and process variable reduction and optimization. So we see what we can, in the controls, in some cases reduce the chemical consumption up to 30%, and at least up to €5 million. New area is this availability. It's extremely costly for customer. So this was one of the newest pulp mill. They have 2.4 million in annual lost production income because of unplanned stop, and we with the industry application we can reduce that with 50%. This is so it's a value for customers 1.2 million, and also the cost reduction, and in some of the technologies energy is extremely costly, and then they have seen an annual energy savings for up to 3 million euro. Valmet Performance Center, that's the way we support our application. So what we have here, for each customer segment we have one performance center. In principle that you have the pulp mill, we have the local experts at the mill supporting, and then we have the Valmet Performance Center sitting and follow the process and supporting customer. And in background, if the people there can't help customer understand, we have the Valmet expert network behind. And services we have is the connectivity. So customer have the pulp mill, customer have the control system, and from the control system we take the data up in the cloud and make the analytics there. And then the customer can see all the analytics we're doing, and also our Valmet Performance Center see the same. So it's no difference. It's a total transparency between what we are seeing and customer seeing. On demand expert support, that's about the customer. We have a ticketing system. Customers send a request either via mail, chat, or phone, and then coming into Valmet Performance Center, they try to solve the problem. If you're not able to solve it, they use the expert network members and then they solve the problem customer and close the ticket. Next service that they have in these agreements is remote monitoring and optimization. Is an example. We have a monthly reporting, and then it's based on agreed KPIs, including process expert recommendation. Each report includes progress follow-up from previous month. And we don't send this report without having a virtual meeting, and we review the report together with customer. Last picture is about our infrastructure then. We have decided to use Amazon Web Services and all the tools inside there for our applications. And coming back to very much for what Dimas talked about, we started this exercise 3 years ago. And what we have seen is this lack of knowledge in data science, it's a really big problem, I would say, for most of the companies, especially when we started. We didn't have the knowledge, and we did a lot of mistakes before. But even if we have support from Amazon, we made the mistakes. So they have changed, for example, from Burst to Tableau, and we have changed from Redshift to Snowflake as the databases. And the reason have been performance issues there. Then we're using Salesforce as a Valmet customer portal login here. Then as also Dima mentioned, it's not enough to have the cloud. We need to be on the edge also. So we're using Krauser here as an edge node. And one important reason for the edge node also is also the connectivity to the customer control system. There are many different control systems customer have. It's not the same. So we need to be able to connect or communicate to all kind of system. And the next thing is, of course, when we can't send, if you have a high-speed data, we need to do the quick analytics, and then we need to do it in Edge and only send up the results. Normally, a pulp mill process quite slow, so every 30 seconds is normally enough, but some application require every 2 times per second data, and then we do the analytics in the edge. Just to summarize that we have working very hard to create more and more smart industrial internet application to predict maintenance failure and improve the performance. And it's always supplied with Valmet Performance Center agreement. And we also need to have the local presence. So we can't just be in the virtual world. We need also to be facing the customer at site.
We're going to move on to our final session now, which is titled Self-Service Software for Your IoT Engineers. Learn how non-programmers can design and deploy an IIoT project. And our presenter is Mr. Goran Appelquist. He's a PhD, CTO, and technical lead for Krauser Technologies. So this session is going to highlight Flow Studio, how a self-service drag-and-drop design studio can speed up design and deployment of IoT data flows. We'll talk a little bit about Edge Director and how to orchestrate, overview, and maintain large volumes of connected assets within industrial IoT. And example flow, an example of how an industrial IoT data flow could be designed and deployed within a couple of minutes. So very quick application there. So a little bit about Goran. He has 20 years of experience in various leading positions at multiple high-tech companies. Krauser is a startup that designs and delivers the industry's first pure play real-time software solution for fog edge computing architectures. He has a PhD in physics from Stockholm University, where he conducted research on data acquisition systems for large-scale experiments, such as the CERN's Large Hadron Collider. So without further ado, Goran, the floor is yours.
Thank you, Greg. Hello, everyone. I will give you a quick introduction to the Krauser Edge Analytics platform. So now we've heard a lot about the benefits and also some of the issues with Edge Analytics and Edge Computing. So in this session, I will try to show you how Krauser has addressed these issues. And I will start with a quick presentation of our offering and then switch over to a real demo and show you what it looks like in real life. So the Krauser solution consists of 2 parts, where the first is the Krauser Cloud Service. This is our management and orchestration platform. So this is the main user interface, and this is where you define the processing that you want to run on the edge using visual design tools. And it's also the tool where you decide where you want to run that processing that you have set up, and also where you onboard new edge devices and monitor your edge devices to make sure that they are operating as you expect. The second part is the Krauser Node. This is a generic software platform that runs the actual processing of data. So this is a generic software platform with a real-time analytics engine at its core. So this is the real-time engine that Johan mentioned that has been developed over quite a number of years and been proven in a number of projects all over the world. So this is a really efficient real-time engine with a very small footprint while still providing high performance. So you can run this also on very lightweight hardware platforms and still get very good performance for processing your data locally. You install it as a single Docker container, and it's the same software that you run on every edge node that you have in your system. And then you configure it with different process definitions that you have built in the cloud service. So you don't have to change the software in the edge when you want to change the processing. It's just a matter of reconfiguring your edge devices. And so what we have tried to do when building this, one of the key design criteria has has been ease of use. Due to all the factors that you have seen in the previous presentations, we realized that ease of use would be one of the key differentiators for a product like this. We need to get out of the space where you need software developers for every single deployment that you want to do. We want to enable a much broader group of people to be involved and participate in the implementation of edge analytic solutions, whether it is automation engineers or data scientists or whatever. So that is what we have tried to provide, but also provide a platform that you can grow with, that can help you from the starting cases where it's maybe just collecting data and send it to somewhere where it's needed, all the way up to running machine learning algorithms or your custom code. So even though these tools enable a much broader user group, it's still a valuable tool also for software developers. They can run their code on this platform or develop their own models or modules using this platform, and then benefit from the tools to deploy the software. Because even if you have software developers, it's still an issue to operate the network of a large number of edge devices where you need to deploy your code and upgrade and maintain your code that you run in the field. So these tools should address all of those different individuals, whatever background that you have. So the way that you design processing in this system is by building flows using pre-built modules that implements different functionalities, starting from modules that collects data using different protocols that connects into your machines to get the data that you want to process, modules for doing different types of processing of your data, filtering, cleaning up, reformatting of data structures and whatever, all the way up to running your AI models that you have built. And then in the end, sending the result to wherever it's needed, in the cloud or on-premise. Then you have pre-built modules for that, and then you just connect them together into a graphical flow, and I will show you how that works in real life in a second here. So when it comes to AI, we have taken the approach that the Edge is a platform where you run your trained models. It's not a platform where you train models or develop models, but once you have a model, you can run them on the edge to do fast and advanced analytics already at the source. So we want to provide a platform where you can run whatever models that you have built. If it's using any of the standard AI or ML frameworks, then you will be able to run it on our edge device. So that's a quick introduction. So let's move on to the demo. And then I should switch screen here. Like that. So now I hope you see my screen. So we're now in the Krauser cloud service, and I will quickly show you. We don't have much time, so it will be a pretty simple setup, but hopefully you will get an idea for how you work with these tools. So we're now in the cloud service, and this is where we start by building the types of processing that we want to run in the edge. So I will open up the editor to work with a flow, and I have cheated a bit by building a simple flow so we can get started quickly. So what we see here is a flow that starts with, on the left-hand side, an OPC UA module that collects data from an OPC server. And then we want to send that data up to the cloud, and in this case I'm using a connector for the Azure IoT Hub to send data up to Azure for further processing potentially, and storage and visualization and whatever services that you want to use in the cloud. Before we start looking more at the flow, just let us have a quick look at the tool itself. So on the left-hand side, we have our module library. So here we have modules. You can pull in modules from the library and then just connect them into flows like that. And on the right-hand side, we have settings for the different modules. So each module has some settings that you that you need to set up to specify which part of the data that you want to process and whatever inputs that specific function may need. Another feature of this tool is that once you have built a part or even a complete flow, you can also test run it from within the editor. So you can connect the editor to any of the nodes that you have in the field, or you can try it out in a safe environment using a sandbox, which is just an edge node running in as part of the cloud service. So then you can test run your flows without affecting anything else. But in this case, just to show you, let us connect to one of the nodes that we have deployed in the field. So then we hook up the editor into this node, and then we can test run the flow on that node and get access to the data that distributed node have access to. So what happens then is that we get a start button up in the corner, so we can actually start running the flow. So let's do that and see what happens. So now the flow is running. We don't really see anything, but what we can do now in the editor is to switch over to the debug view here, where we can see the messages as they come through. So if I switch on debugging on this module here, we see that we do get some data from the OPC server. So let me just stop that so we see what happens. So when I turn on debugging, the module will show what it receives on its input and what it's delivering on its output to the next module. So we see that we get a number of different data from the OPC server. We get one message per tag. I've just set up a few tags that we read out here. I think it's 3 tags that we get from the OPC server. So we see the name of those here. If it's probably a bit hard to read, maybe I can zoom in a bit. That was not so good. So we get a lot of data for each of the sensors that we're reading. And in this case, we're actually not interested in all of this data. We're just interested in the tag name and the actual value, which is part of this message. So I added some additional modules in between here. So the next module is actually a module that we can use to convert the format of the messages, because that's an issue with most of the IoT projects. You get data in lots of different formats coming in, and depending on where you want to send the data, you need to provide data in a specific format. So therefore, having the possibility to change the structure of your messages is a quite important feature of any processing system like this. So I use this module here to actually just pick out these two, the tag name and the value, and I will also rename this property is called friendly name. I will call it just name. So if we clear out this and start the flow again, we can see what happens in the next module. I will stop it there. So we see this is the data that came out of the OPC module, lots of different metadata associated with the values. But on the output, I have now reduced that into a simple message with just the name of the sensor and the value that it provides. So just the basic operation, but with this module, you can restructure the message in any way you like. So you can change the hierarchies of data and so on and create any type of message that you need. And then we want to send this to the IoT hub. You can send any type of data format there, but we need to serialize it to be able to interpret it at the other end. So therefore, I've added a JSON module here to convert it into JSON format, and then we send it to the IoT hub. So that's a very basic flow. But if I start that, then we will also take a look at what happens on the other end. Now I haven't found any good way to actually see what you receive in the IoT hub using the Azure portal. So I'm going to use the Azure IoT extensions to Visual Studio Code to show you what is happening. So I have that here, and the device I'm using for this demo is called Demo. So we can turn on monitoring of messages for that device, and then we see that the messages are coming in just like we have them in the Edge device. So that seems to work. So we have a working flow now, sending data to the IoT hub. So let's go back here and stop that. We can leave the editor. Let's save that flow. So now we have a working flow. We haven't deployed it anywhere yet. We just test run it on a device, but it's not running anywhere. So the next step, once you have designed your flow is to deploy it onto some of your edge nodes. And we can do that from here by using the deploy function. And then I can either select one or a few of the edge nodes that I have and deploy it on those, or I can use another feature, which is to use labels, and that is a concept we use to create groups of nodes. So a label is just a text string that you can attach to a node, and each node can have any number of these labels. So in this way you can create different groups of nodes and then operate on a group of nodes with these kind of operations. So let's select one of these groups. I will select this one called machine because that was the one that we were testing with. So if I select this label, I will deploy this flow onto all those nodes that have this label attached to it. So let's see what happens. So then it will start deploying the flow. It will take some time, and the reason for that is that all the communication between the edge nodes and the cloud service is always initiated from the edge nodes, so you don't have to open up ports for inbound traffic in firewalls and stuff like that. So they will call back into the cloud service on a regular basis, every 10 seconds in this case, and check if there is something they need to do. So it might take up to 10 seconds before you have everything up and running. But now we see that in this case there were 4 nodes that had this machine label attached to it, so it will deploy it on those 4, and it's now up and running on those 4 nodes. So that's basically how easy it is to get started with setting up some processing and deploy it on a number of edge nodes. Once you've done that, now this was really basic stuff, but let's do some small modifications to the flow to see how easy it is to work with flows like this. So another concept here is that we have versions of flows, because we know that you will always want to change stuff, and you need to keep track of what you have done and what is running where. So as soon as you have deployed a flow onto some edge nodes, then the flow is locked for editing. So I can no longer change this one. If I want to make changes, I have to create a new version. Another thing to note is that now once we have deployed the flow, the edge nodes are independent from the cloud service. You can actually disconnect them from the internet, and they will still continue to run autonomously at the edge and do the processing that you have defined. So you can disconnect it from this service, and they will still run. Another thing to note, maybe that could be understood maybe from the flow, but might be worth pointing out, is that the actual sensor data is never sent to this cloud service. This is a pure configuration tool. So the sensor data is sent to wherever you define when you build these flows. So it goes straight from the edge node up to Azure in this case. So let's do a quick modification of that flow just to show you how that works. So we create a new version. This is the same one that we left off with, and let's do some simple changes. Now we didn't do anything with the data, so let's add something in between here to do something with the data. Let's do an aggregation just to reduce the amount of data a bit. So we add that module in between. We want to aggregate per sensor, so we group the calculations on the name of the sensor, and it's the value that we want to aggregate. And then we assign the results to a property called data. We can remove this one. We want to aggregate over some time. Let's do 5 seconds so we don't have to wait too long. Like that, that should be enough. And then we can add one more thing. As you see here, I have another output that I haven't used. So let's use that one as well. Let's say we want to create a message based on some condition and send that message over Slack. So let's add a module here that we can use to create a text message. So here we can create text messages and use data from the incoming message to as part of the text. So let's see, input, if we use these curly braces, I can use data from the message or from the flow. So we use the friendly name, so we can see what that is. Data from that sensor. It's out of range. Maybe we want to show the actual value as well. So we take the value from the message. And that was called data.value. So we create the message like that. So this message will be created every time we trigger this module by sending some input. But now, to make this a bit more useful, we want to define some condition. And this is a feature that you have on all the modules, that you can set up a filter that specifies on exactly what messages that should affect this module. So let's say that we want to, actually I will do like this. We can copy this. I don't remember the name of it. Let's do it like this. I didn't remember the name of the tags. So let me just copy the name of so we say that the friendly name, and then you need to spell it correctly. Friendly name should be equal to that. That's the string. And then we want to check the value. And let's say that we want to check if it's less than 0, then we want to send a message. So we had 2 conditions here. Let's just make sure that it's correct. Yes. Okay. So let's connect that and just test that this is working before we. So we connect it again to the Edge node that we had there. Then we take a look at yeah, so we do get some messages here. It's probably hard for you to read, but this is the text that I wrote. So when this triggers, we get this message coming out. So that looks fine. And then we can just connect it into the Slack module. So then if I test this again and open up my Slack window, we should hopefully see no. Something went wrong. It was my mistake. I forgot something. We need to have the right name of that text, the property for the text message, so the Slack module can pick it up. Let's try again. Yeah, now it works. So if we take a look at Slack, we see that we do get, I can also open up the so now we get the message sent to Slack. So that is also working good. And we still have the messages being sent to the Azure IoT Hub. So everything works, it seems. So we're happy with that new flow. So let's save that and leave the editor. So now we have a new version of the flow. We see that all the nodes are running the previous version. So we will now upgrade these nodes to the latest version. So you can do that. You can upgrade just one of the nodes to test it if you want, or you can upgrade all of the nodes and say that I want them to run the new version. And then we stop the previous version and we start the new version on those nodes. So in a while we should have all 4 nodes up and running with the new version. So that's how easy it is to upgrade the processing that you run on each of the nodes. Now we made very basic stuff in here, but of course you can add much more advanced processing in between here, or you can go all the way and plug in a Python module where you run a machine learning algorithm. But the principle is the same. You drag and drop these modules and then connect them together to define the processing that you want to run. So that's how you set up processing. The final thing I wanted to show you was just the dashboard. So even though the actual sensor data is not sent to this tool, we do collect some statistics from the nodes, both so you can see how much traffic that is flowing through each of the nodes, and you can also see the load on the local hardware, both the status that they are still connected, but also the load on the local hardware, so that you can make sure that you're not deploying flows that are overloading the local hardware platform that you run them on. So this tool gives you a snapshot of the status of all your nodes, so you can make sure that everything is up and running as expected. So with that, I'm done with the demo, and hand over back to Greg.
Excellent. Well, thank you so much for walking us through the product, Goran. It's always a wonderful addition when you can actually see a live demonstration of something and see some of the nuances of how it works. So I appreciate that very much. I'd now like to invite all of our speakers back to the virtual podium for our Q&A session and panel discussion. So while the folks are taking themselves off of mute, I'd like to invite all the attendees, if you do have questions, there's been quite a few that have come in, both on the live portion of the Zoom as well as coming in through social media. So please keep firing those in. If by some chance we don't have time to address all of those, we will be addressing the questions post-conference as well via Twitter. And once again, that Twitter is hashtag IIoT Edge, EDGE. So I think we've got everyone back unmuted at this point. So why don't we kick it off with just kind of a general market overview question. Yeah, if anyone wants to comment, we've had a couple questions come in around the nuance of how fast do you think the current market is going to evolve? So would anyone care to offer an opinion on that front?
Yeah, I'm happy to start, and maybe other folks can jump in if they have other things to add. I mean, I think the market evolution in IoT is sometimes described as sort of a trend line with sort of one line on a graph, but I think it's much more complicated than that, because there are many different types of IoT solutions that are out there, both from the complexity of the technology side as well as the business value that's being achieved by the business. And so from what we're seeing at Mach Nation is that there's a lot of low-hanging fruit when it comes to IoT, and those things are moving along fairly quickly. These are the solutions that basically give you visibility into certain kinds of data that wasn't available before, fairly low-risk deployments. And then there are more complex, more nuanced technologies involving machine learning and artificial intelligence, much more sort of an actuator model where you are controlling things from a centralized location. Those take longer to evolve because there are a lot of operational and business challenges associated with getting those involved. But I think the most important message that I would leave the listeners with is that there's a lot you can do with IoT today. Technology is already there, and it really just takes the business and the buy-in from the stakeholders within the business to push it forward. And I think that's probably today more of an impediment than the technology alone when it comes to some of the simpler, more predictable types of IoT deployments.
No, great. Thank you for the insight. Anyone else care to comment on that question, or should we move on to a couple more? Okay, hearing no takers. Like I said, we've got quite a few to work through here. There's several came in from Bill. The first one being, how will the move to decentralized computing, example HashiCorp, etc., impact the IIoT space? And then a follow-up to that is, will IIoT implementers jump to the containers, microservices world as part of deployments, or are they going to stick to classically development approaches?
Yeah, maybe I can comment on that. I mean, from Krauser's perspective, I think we already made the decision and go for containers. And from what we have seen, that seems to be the sort of both accepted and expected way by most of the customers we talk to. Most of them feel pretty comfortable with containers and see the benefits with that. I mean, it becomes so much easier to manage the life cycle of software when you run with containers, and especially I would say for these type of edge deployments where you might have hundreds or even thousands of different installations of software running, then the the life cycle management is a key part of that. So simplifying that is really important. Then of course there is still a lot of legacy or older type of hardware infrastructure out there. So it might not always be possible, but for us at least it has not been a barrier to entry with any of the customers. It's always been an acceptable solution and they see the benefits of that.
Yeah, I would agree with that. I think when it comes to sort of edge deployments that have quite a lot going on at the point of asset data generation, that's where that containerized management is really key, because you're generally introducing some new technology to make it work. As Joran said, I think in older technologies where you may be trying to retrofit something, if it's more of an OCI stack that's going to be leveraged, if you're doing something very basic at the edge, just sending data up into the cloud, then perhaps less of a need for containers. But as you need to manage those containers in those more complex deployments, sort of anything other than a modern sort of cloud architecture at the edge is probably a difficult sell in 2019.
Excellent. Had a question come in from Jean-Luc. And this was for Valmet. It says, what solutions do they use to collect, process, and visualize information?
Yeah, I think it was also explain how we visualize it. Yeah, we're using this Tableau. But we visualize the dashboard in Tableau. Was that the question, or?
Okay, I think that may answer it. Jean-Luc, if that addressed your point, no need to comment further, but if there's something else that's outlying there, please feel free to shoot us a note back in to clarify, and we'll be happy to answer that further.
I would say a lot of things that Dima talked about in the beginning, the 5 takeaways, is really on the bullseye also for us. It's really, that's the life have been for us. It's not easy to just, he said that not building your own system, but even if you select Amazon Web Services, you're kind of building your solution inside that environment. Do you want to comment that, Dima?
Yeah, that's right. I mean, I think it's you know, that I think, you know, there are technology building blocks that matter, you know, whether you use Tableau or whether you use Power BI. I think at the end of the day, you know, for me, when I make recommendations about how companies approach it is, you know, figure out what value you want to get out of a specific solution, and then you go into sort of, you know, a hands-on evaluation of a sort of a leading top 3 or top 5 vendors, and you first start with a very brief sort of higher level overview. You might be able to eliminate some based on, you know, certain obvious limitations, and then you really have to go in and you have to try it. You don't build the full solution, but you build enough of a thin thread, enough of a straw man to make sure that you can validate the requirements. But I think when it comes to visualization in particular, I think that isn't sort of what's holding us back in IoT, because there are so many good visualization technologies that exist for other industries, you know, CRM, ERP, that the challenges are mostly elsewhere.
Got it. Okay, we had another question this is from Bill, and it says, is distributed ledger technology a core part of making industrial IoT trusted, as the air gap is eliminated and/or one is working across these complex systems that were not designed for robust trust and identity management originally? That's a pretty insightful question. Does anyone care to comment on that?
Yeah,
Go ahead.
No, yes, start you, Dima.
Okay. Well, I think, you know, when it comes to blockchain, you know, from our view, it's a topic that gets brought in a lot. I think there are some valid use cases for blockchain, but oftentimes when we hear about blockchain being used, it's more of a buzzword today. There are a lot of technologies where we hear blockchain is being proposed where sort of relational databases and access controls are probably sufficient. So I think there is potential for this technology. I don't think it eliminates the air gap, but there's potential for this technology to create a more decentralized security model. But I think it's important to make sure that you measure twice and cut once when it comes to deciding whether you deploy something that's fairly nascent and fairly new and fairly immature in a setting. I think you would be sort of a guinea pig for this kind of stuff if you were to be deploying it today, but certainly important to keep it in mind from a roadmap perspective.
Yeah, I fully agree with that. I mean, we do see some talk about that, but that's what it is today, I would say. I mean, and of course there are issues with data security in these applications, but I'm not sure blockchain, at least that as it looks today, is the solution that will be chosen, but we will see.
Right.
I had a question from Santiago, came in here, he had several. I said for Valmet's interlocutor, one question he had was, are there efficient alert systems available in real time with the overall performance derived from the interference or the inference of model updated periodically? For example, the state of the operation in Yankee of a Pulp Fiction machine, or a Pulp Fiction, kind of movies on the mind, of a pulp machine. Thank you.
Okay, first of all, remember that if you really want to have some real-time update information, then you have the local systems. So the pulp mills, paper mills all have a control system locally. So what we use for cloud is not real-time analytics. It's kind of delayed. So it's no problem for us to do the analytics, let's say 1 minute later after it's happened. So you really need to consider, if you don't want to have something immediately when it's happened, then you need to be on the edge to do that, not moving. So we're moving the data in batches up to the cloud. Is that answer the question?
Okay, well, Santiago, if that didn't address it, please raise your hand again, and we can clarify further. Kind of on a similar path, I'll throw this out to everyone. We had a question of how relevant is machine learning for edge analytics?
I could start. So I think, it's sort of a similar answer to blockchain. I think it's much closer to being relevant today than maybe blockchain for some of the edge technologies. But I would say, from our perspective, most companies are not at a point where machine learning is where the problem that they're trying to solve. I mean, machine learning is essentially a very advanced technology to automate things or to generate data. From a lot of the actual IoT deployments today, there's a lot more sort of simpler statistical methods and algorithms that can be used to derive a lot of value. And so again, machine learning is something that we think people should be planning for in terms of determining whether the technology will support it in a couple of years. But when it comes to today's deployments, I think sometimes it can get companies into a bit of a mess because it's again, a fairly new concept for a lot of industrials, and it's important to sort of, go for a target that you can really find success with internally, and then improve and expand to areas like machine learning, artificial intelligence, and other technologies that have tremendous value, but also have complexity that is being introduced by them.
Okay, go ahead. Yeah.
No, I was just going to say, I mean, that's exactly how we see it as well. I mean, AI and machine learning, that's the final optimization that you can do, but and there's definitely value in that, but there is a lot you can do without machine learning. And also what we have seen so far is that machine learning models today to really provide value, then they have to be very customized for a specific use case. So it's not that you can just pick a model, a generic model for something that seems right, almost right. I mean, it has to be quite tailored to a specific use case. So it's a pretty advanced thing to do, and it's probably not where you should start.
We have in Valmet started using machine learning. I think it's often the right solution because they have quite dynamic processes. If you change the chips that's coming out, it's a software, hardware in a pulp mill, then you get other conditions. So you need to have a model that's developed all the time. There's so many conditions there that affect the process. So it's not enough to have you need to have a dynamic model to be able to predict.
Excellent. So I have a question here for Joran. It says, how do you address on-premise IoT and the complexity surrounding such use cases? Do you use cloud, edge, or both? And then as a follow-on, how do you predict the IIoT future?
Wow, that's a lot in one question. But
it's a mouthful, I know.
Yeah, when it comes to on-premise, I mean that's actually one of the drivers for edge analytics. If the output of your data analysis is going to be used on-premise only, whether that is to feed another machine or to some local ERP system or whatever, then of course edge computing is a perfect fit, because then there is no need for the cloud. Then it's better to keep the data locally and do the processing there. So that's definitely one of the reasons why we have edge computing. Then there are of course other issues, which is maybe not just on premise, but like we just talked about with data integrity and so on, where you maybe don't want to send the raw data to the internet and you need to do something with it before you can send it, whether that is to provide more aggregated data that is not so sensitive, or anonymize the data and so on. You can also do that on premise to help you connect your data onto the internet. And another issue is this question of who should get access to what data, because what we see in many projects is that there are multiple parties that are interested in getting access. And of course the factory owner sort of have access to everything, but there are other parties that are interested, like the machine manufacturers, or there could be other service providers that want to derive value, but maybe the factory owner is not willing to provide all the data to those. So you need a way to be able to separate the data and provide in an easy way control who gets access to what. So there are a lot of issues, but I think in many cases on-premise issues, their edge computing can help. But then to address the second part of your question, cloud, edge, or both, then as Deem already pointed out in the introduction, we totally agree with the hybrid approach. I mean, you need both. Neither of these two will solve everything. There are use cases where edge makes sense, and there are other use cases where cloud makes sense, and to get the most output of any IoT setup, then I think you will need both in combination. That's what we will see going forward. Then there are of course still a lot of issues. I mean, it's not always easy to connect from a factory floor to the internet and so on, due to how the infrastructure in factories and so on are set up. So it's a way to go, but I think in the end that's what we will see. So I think IoT, industrial IoT, has a bright future, but we're at the starting point on that path. There is still a way to go, but there is definitely a lot of value, and I'm very confident that there will be a lot of value derived out of these projects going forward.
You know, kind of I guess a follow-on to that topic in general, Bill had a question that he submitted. He says, will edge analytics demand the need for overarching, trusted, fluid computing environments, that move applications to and from a more centralized but a higher compute system? When you see opportunities that are going to evolve there?
Yeah, I think there will probably be more demands going forward for controlling and I mean, how you deploy these softwares. Now we're still sort of early stage, and you can maybe accept a little more flexibility there, but I think that is something that needs to be addressed, and exactly how that will be solved and what type of security and so on that it will be needed, I think is still something that is open and needs to be sorted in some way or the other, and I don't know exactly what the end result will be, but I'm pretty sure that it will be a more tightly controlled environment maybe than we see in many projects today.
I see. Any I'll throw this out to everyone. I mean, what are your insights regarding skill level and company resources among your clients, customers and their partners?
From our perspective, this is Dima speaking. I think when it comes to industrial companies, I think they, where these companies excel is the domain expertise and understanding the area that they're in, the vertical in, and their use cases that they are addressing for their customers. So there's a lot of expertise and understanding what the company has been successful with. I think where there is generally less expertise is around some of this data science work that I briefly mentioned in my opening remarks, where IoT is really all about generating some kind of actionable insight from the data that's being gathered. And some organizations have data scientists and some organizations have folks that are doing analysis on a lot of data, but even those that do oftentimes don't have enough folks to deal with the complexity of the data that's being acquired from IoT. And so I think that's definitely a challenge, because it's for one, those companies generally don't have those people, but also from the job market perspective, it's not easy to find people that have both an understanding of some of the domain areas as well as have that data science background. So it's definitely a challenge to find the right talent. And I think why a lot of self-service analytics is something that can, at least in the short term, help bridge some of that gap today.
I want to poke a little bit more on that question. So do you, and I'll throw this out to everyone once again, I mean, do you see challenges there related to what I would call the academic side of it? I mean, you say it's hard to find the talent. Is it hard to find the talent because there's a shortage of skilled labor in this area, or do you think it goes beyond that, where the academic side of it's simply not producing the products that are desirable to you, i.e. the product being people with this skill set?
I think from my end, I think it has to do a lot with demand, which I think will eventually be satisfied by sort of the academic side. More people going to the space. But from my end, I think it really has to do with demand, and also a lot more sort of applied data science rather than just very pure sort of theoretical data science, which is useful, but it's not something that is necessarily very translatable to understanding a specific domain.
Gotcha. A couple questions came in for, I'm sorry, go ahead. Did you want to comment on that?
Yeah, I just had a brief one. I mean, we're talking about the analytics side, but I would say that there's a little gap as well in terms of communication, though, like data communication and people that, I mean, the machine manufacturers that we meet today, they have engineers for building the low-level languages and connecting their machines to the automation system in terms of how to set up networks and understand the complexity of that and everything. So I think it's both, the analytics side is very obvious, but there's like, how to say, a dark space or forgotten space is just the stuff between the machine and where it's supposed to send the data. And I think that so forth, the software integrators are doing that job, but still there are still so many cases that need staffing. So I think that that's also where the skill shortage is actually showing.
Okay, no, thank you. I think that's insightful as well. I had a couple questions come in for Valmet. How does Valmet target the global complexity of IoT in terms of architecture, technology, or technological options?
It looks like we may have lost Thomas. I don't see him on the panelist list.
Okay, well then we'll see if we can jump back in then. Well, I'll throw this out, another question to the collective then. PDM is a big topic, but what other business drivers do you see out there in the industrial IoT space right now?
Yeah, I think.
Dina, please start and I'll continue.
Okay, yeah, I would say, predictive maintenance is a big one. I think sort of just asset tracking and visibility into a lot of data that wasn't available before, and bringing data into a centralized location after normalizing it and analyzing it at the edge is I think a really big value add. So just kind of visibility and monitoring, I would say, is another big element that's relatively low hanging fruit compared to some of the more sort of lofty and complex things that analysts like to talk about.
Yeah, I agree upon that. I also think that how do you say, there's a lot of companies that they haven't specified the business case yet, but the driver is to just start collecting data, because they've learned over the last couple of years that it's important to have a huge pile of data for doing this historical training of the algorithms. So therefore they're just they start gathering data just for the purpose of it. They don't. So I think that's also something that come up over during the meetings and the customers that we have.
And also,
along the same lines. Oh, go ahead, finish your thought.
No, I was just going to comment on Thomas' slide, since he's not around any longer. But I mean, process optimization is also a key part, as we saw on his slide. I think the biggest saving was actually on the process optimization side, which is another area where you can use the data that you collect.
Okay, good insights. In terms of just data in general, do you think classic data historians like OSI Soft are going to remain the leaders for data storage, or do you think companies like Influx Data are going to disrupt them, or even new startups? Any thoughts around that?
I can start. I think that players like OSI Soft will definitely have a role, because they are so embedded, they are so involved, and they are so deeply integrated to the systems that it's the business case to remove them or is actually too big. So therefore I think that these kind of players are going to have a pretty strong position in this market and then startups and other systems will gather around and help these systems to evolve. I mean, being a part of the development of and you can see that, especially in your mentioning of OSI Soft. I mean, they are opening up for that purpose, make it very easy for they have realized that they need an ecosystem to keep the position that they have.
And I also think that we will see historians move from the factory floor to the cloud, to have more centralized historians, so you don't have one in every factory or every process segment or whatever it is. But then it could still be the same companies delivering the software for that, but I don't think we will see that it moves upwards.
No, good insights. No one has a crystal ball, but I think it's always hard to dismount an 800-pound gorilla when they're entrenched, and the changeover costs to go with something like that are tremendous too. I think you're on the mark there. I think we can go back to some general market questions as we kind of wrap up our session today. Who do you think are the pioneers in this industry, and then who do you think are going to be the second wave of companies to embrace IoT in the industrial sector? Any thoughts there, gentlemen?
Well, so from my perspective, I think, companies that, especially if we look at edge computing and how self-service software sort of helps enable IoT deployment, the pioneers that we see in the market are generally enterprises that have really high value assets that they want to connect. I'm seeing, that's where there's sort of much more value to an IoT solution. And so if you have not talking necessarily about, millions of assets, but maybe, 100 or 1,000 or maybe a couple of thousand assets that are really, really, really high value. And there's just so much to be gained from figuring out predictive maintenance or asset monitoring or any of those types of solutions. I think that's where the pioneering is. And I think as the technology becomes more mature and the costs of entry start to become lower, and you start to have a little bit more of a sort of a workflow and pathway for how IoT is deployed, some of the companies that have slightly lower margins on some of those solutions will start to enter the fray as well, because they will start to find it sort of a cost positive approach to some of these deployments.
Gotcha. Good insight again. Can anyone speak to, I know we've heard obviously some cases about the pulp mill and the application, but what are some of the more common use cases that you're seeing out there?
Göran, do you want to start or should I?
You start.
I can start. Now, I would say that the most common use case that we meet today is just we have a Swedish for it, but it's just mainly connect, collect, and send. It's just like the most. It's like the simplest way of getting connected because they know what they want to do, but they are still struggling with infrastructure, or security, or protocol issues, or like just making everything to work. So I think that today the use cases that we see are the most simplest one. They are not that difficult. It's a lot about just getting data. But then as soon as they realize that the first step or has like go past that one, I think that like remote monitoring or process optimization is I would say is the most common one due to my knowledge.
Let me ask you a follow-up on that. I mean, we haven't touched on cybersecurity much at all today, but how large of a concern is that coming from your existing client base when you come in to do a system integration or a product launch? Can you speak to your clients' positions on cyber? I mean, is this a scale of 1 to 10? Are they can't sleep at night versus could care less? Maybe give us some perspective there.
So I guess from our end, from Automation side, of course, security is a very important element. And I think everybody cares about security. Where I think is, our view is a little bit different than maybe what we hear a lot in the market is I don't really envision that, I don't really see that security is something that prevents you from exploring IoT. I think it's a consideration that's always there. But from my perspective, security sometimes is an excuse not to do something because you don't have the executive buy-in internally or you haven't quite figured out what value you will get. And then, of course, introducing something that doesn't have clear value is not a good position from a security standpoint. But from our view, once companies have identified the value that they will get, it's a calculated risk approach, just like any kind of technology deployment or business process change. And it really comes down to, using a holistic security approach, having secure building blocks as well as making sure that the solution is secure from end to end. But it's rarely in my mind that the real reason why people don't do something with IoT today.
Good perspectives, very good perspectives. Well, we are at the noon hour here in Eastern Standard Time, so we're going to wrap our session. I'd like to thank everyone for taking the time to join us today. I'd also like to thank our panelists for their outstanding contributions and great insights into the vast world of industrial IoT. Stay tuned for other educational webcasts to be brought to you by IIoT World. Over the next couple of months, we have the following topics scheduled. We have an industrial cybersecurity webcast in the healthcare sector targeted for February. And then on the heels of that, we're having a driving ROI out of IIoT, connectivity, AI, and IIoT, and a session on remote monitoring, as well as numerous other ones that are in the works. So a special thanks to our sponsor, Krauser Technologies, for this educational session today. Feel free to subscribe to our newsletters, YouTube channels, and you can also follow us on Twitter at IIoT_world. So this concludes our program for the day. Thank you all for attending. Make it a great day.